Okay, so for question number 1, I originally had a standing wave, but the correct answer is D, interference. When two sine waves of equal amplitude and frequency occupy the same space and time, but are at opposite points in their sine oscillation, they will interfere perfectly and cancel one another out. Question 4, I had C, but the correct answer is D, 9.0. And the equation equals 2 pi squared L over G. And then, so T equals L2 squared, which equals T over T, which equals K, which equals 9. For number 5, my original answer was A, but the correct answer is C, 8 meters. Number 7, I had A, but the correct answer was B, higher. This happens because of the Doppler effect. Number 10, I had B, but the correct answer was A, 0 displacement. At a 0 displacement, the potential energy is 0 because the pendulum is at the bottom of its swing, so therefore all the energy is kinetic. Question 11, I had B, but the correct answer was C. It stays the same. Frequency doesn't change the position, so that's why it stays the same. Number 12, I had D, but the correct answer was A, a longitudinal wave. The particle motion and the wave velocity are parallel to each other. For number 14, I had C, but the correct answer was A, halves. And so the original equation is P equals 1 over F. So if F is doubled, then P equals 1 over 2F. So then that turns into F equals 1/2, which is then P equals 1/2 times 1 over F. So then 2P equals 1 over F, which then turns into 2P equals P, and then P equals 1/2 P. So the second period is half of the first period. Number 18, my original answer was A, but the correct answer is C, shortened. The center of mass changes when the child stands instead of sits, creating the time for to and fro of the swing to shorten. Number 20, I had B, period, but the correct answer was E, wavelength. Number 21, I had A, but the correct answer was C, shortens. When frequency increases, the wavelength decreases, so the wavelength shortens. And number 23, I had B, but the correct answer was A, away from the normal.